Welcome to The Explainer. Today, we're pulling back the curtain on how computers are learning to think, to reason, and yeah, even to speak our language. We're going to explore the fundamental ideas behind AI and see how they're already changing, well, pretty much everything, from our health to our laws. I mean, you hear the term AI just about everywhere, right? It's on the news, it's on your phone, but what does it actually mean? How does a machine really think? Let's dive in and unpack the core concepts that make this whole thing work. So to really get a handle on this, we've got to look at its core components. The best way to think about it is like a set of building blocks, where each one gets a little more specific and honestly a lot more powerful.
Okay, so at the very top, the big umbrella term is artificial intelligence, AI. This is the grand vision, right? The whole idea of creating machines that can simulate human intelligence. It's the entire universe of this field.
A great way to picture these concepts is like those Russian nesting dolls. You know the ones? AI is the biggest doll on the outside. You open it up, and inside you find machine learning. This is where systems learn from data instead of just being programmed with a bunch of rules. Then, you open that one up, and you get to the very core, deep learning. And this is the really powerful stuff that uses complex, brain-like neural networks to find super subtle patterns in massive datasets.
And here's where the really crucial shift happened. You see, old-school AI, what we call symbolic AI, it was all about rules. Programmers would spend ages writing these enormous if-this, then-that flowcharts. But modern machine learning, it completely flips the script. Instead of feeding it rules, we just feed it tons and tons of data, and it learns the patterns all by itself.
All right, so now let's talk about the next piece of this incredible puzzle. How do we teach these intelligent machines to understand something that's so uniquely human, our language?
Well, that's where the field of natural language processing, or NLP, comes in. This is the magic behind the curtain that lets you talk to your phone's assistant, instantly translate a website, or get a surprisingly coherent answer from a chatbot.
Now, for a long time, NLP worked in a very rigid, step-by-step way. A computer would first break a sentence into words, then it would analyze the grammar, then try to figure out the meaning, and finally attempt to connect all the sentences together. It was very methodical, but it had a really big flaw.
And that huge weakness was context. You see, these older systems could understand individual words or even the grammar of a sentence pretty well, but they really struggled to grasp the subtle stuff, the sarcasm, the nuance, the big picture that connects ideas across a whole conversation. They just missed the forest for the trees.
This is where the real game changer came in. A new kind of model called the transformer architecture. It changed literally everything. As this quote explains so well, these models can see an entire block of text all at once. This lets them grasp that crucial context. And that is the engine that powers the amazing tools we're all using now, like ChatGPT.
So, we've got the building blocks, AI, machine learning, and this powerful new NLP. Now let's look at how they all come together to create these incredible tools that are, believe it or not, already a part of our daily lives.
Let's start with healthcare. AI can now look at everything, your genetics, your lifestyle, even environmental factors where you live, and spot the early warning signs of a disease long before they'd ever become obvious. This is leading to a much more personalized, a much more preventive kind of medicine.
Or how about the legal world? NLP tools can now just blitz through mountains of legal documents, case law, all this evidence, in a matter of minutes. I'm talking about a task that would take a human paralegal weeks. And by doing that, they can find the key precedents and help lawyers predict the most likely outcome of a case. It's wild.
And what about education? Well, generative AI is basically creating a personal tutor for every single student. Just imagine a chatbot that doesn't just answer a homework question, but then creates a custom quiz right on the spot to make sure you actually get the concept. And it's available 24/7.
In biotech labs, researchers are using AI to make sense of just incredibly complex data from their experiments. By spotting patterns that a human might never see, AI is dramatically speeding up the whole process of discovering and developing new, life-saving drugs and treatments.
Okay, so AI is already transforming our health, our laws, our classrooms, you name it. So what's the next big leap? I mean, where is all this technology heading?
You know, the next frontier isn't just about getting better and faster at finding patterns in data. No, the truly revolutionary step, the next big thing, is teaching these machines to understand the difference between two things being related and one thing actually causing another.
This is all about moving beyond simple observation. See, today's AI is fantastic at spotting correlations. It can notice that, say, ice cream sales and shark attacks both go up in the summer. But an AI with causal understanding would know the reason why. It would know that hot weather is what causes both things to happen. That is the huge difference between just seeing a pattern and actually understanding how the world works.
And that leads us to the biggest challenges that researchers are tackling right now. First, building that true causal inference into these models. Second, getting them to really understand the messy, unstructured context of the real world. And finally, a huge one, making their conclusions explainable so that we humans can actually understand and trust why an AI came to a particular decision.
The pace of this change is just staggering. I mean, we've gone from simple rule-based programs to machines that can learn, they can converse, they can create. And it leaves us with this one profound question. As we build machines that can truly understand our language, what will we ask them to do next?